is Integration with Alyssa Cisneros. So when referring to integration, I'm talking about calculus, not this integration, although that was awesome. So, quick clarification. The derivative of a function evaluated at some point in this picture where x equals a gives the slope of the curve at such point, whereas the integral gives the derivative's function, and when defined over a range, noted b and c, gives an area under this curve. Now that we have, a good clarification of the two, today my example of integration is with an indefinite integral. So here we have the integral of 3 minus e to the x divided by e to the 4x dx. Since this is a messy problem, we'll split the integral into the sum of 2. Alright, now that we split the integral, we're going to need some simplification. Alright, so I want you guys to remember this, and I have that, voila, right here. Now that we have that, we will simplify the first half. We simplify this by pulling out the constant and then moving this up. Now we must simplify this half, and we do that by taking the negative and pulling it out, and then since these are both exponents, we use the rule of exponents and just subtract 1 from 4, and you get negative 3 dx. Alright, now that we have the two simplified, we actually get this equation, which again, I will give you right here for the next part. So, this first half needs to be more simplified. The way we're going to do that is with u substitution. So in order to integrate, we need to substitute. What we're going to do is we're going to pick u as being this negative 4x, and then we're going to have du, which equals negative 4 dx. We need it to equal dx, so what we do is we divide by 4, and we end up with a negative 1/4 du to equal dx. Alright, that being said, we get this little mess, and after a little bit of simplification, we get this lovely clean half of our sums of integrals. Now that we have that, we can write that out as such, and we are good. Next, we are going to integrate the second half, and the way we do that is by taking the second half. Again, we can't use u this time, so we're going to use v. Our v is going to equal negative 3x. dv will equal negative 3 dx, which divided by negative 3 will give us dx by itself, so negative 1/3 dv equals dx. As such, here is a messy little version of all of that with v plugged in. And then we get the cleaner version, which is 1/3 e to the v dv. Alright. Now that we have this, I am going to bring that up here on our sheet. So there's all the work that we've done so far in this whole problem. When we plug in both v and u, we get the final equation, which equals this. We add the plus c because we do not know what the constant is, and being that this is the derivative of a function, that constant gets dropped off.